All right, let's jump right in. Today we're going to talk about one of the most transformative technologies out there, something that is, no exaggeration, shaping our future as we speak: cyber-physical systems.
I mean, really think about that for a second. Imagine a world that isn't just connected, but is self-aware, self-regulating, and is constantly, in real time, optimizing itself. It sounds like science fiction, right? Well, it's not. It's the reality being built right now.
And this is the core promise of what we call cyber-physical systems, or CPS. This is the technology that's literally the backbone of the entire Industry 4.0 revolution.
So what is a CPS? Well, at its heart, it's a system where computer algorithms are deeply integrated with the internet and with actual physical machinery. They use sensors to see the world and actuators to act on it, creating this constant two-way feedback loop between software and our tangible reality.
Now, to really get this, it's super important to understand how CPS is different from the Internet of Things, or IoT, which you've probably heard a lot more about. They seem similar, sure, but their purpose is fundamentally different. You see, IoT is mostly about connecting things and gathering data, whereas CPS is all about advanced control and actually creating physical feedback.
And this, right here, is the absolute key. Think of it like this. Your smart thermostat? That's an IoT device. It observes the temperature and sends data. But a self-regulating power plant, that's a CPS. It doesn't just collect data about energy demand. It uses that data to autonomously manage the physical flow of electricity. It doesn't just watch, it acts.
Okay, so we get what they are. But how do these systems actually work? How do you build that bridge between the virtual world and the physical one? Well, it all comes down to a really clear, structured architecture.
The industry standard is something called the 5C model. First, sensors create a connection to the physical world. Then, all that raw data gets converted into useful information. At the cyber level, and this is super cool, a digital twin, a perfect virtual copy of the physical object, is created. From there, the system enters the cognition stage, where it diagnoses problems, before it finally hits configuration, where it sends commands back to the real world to manage itself.
And this isn't just theory, The business case for this is huge. When you apply this to something like predictive maintenance, letting a system figure out a machine is about to break and fixing it first, companies can slash their operational costs by up to 25%. That is a massive impact.
So, with that architecture in mind, let's look at how this all comes together in real-world applications that are already transforming industries, from the factory floor all the way to the operating room.
In smart factories, CPS is really the engine of Industry 4.0. We're talking about machines that literally talk to each other, making their own decisions to boost productivity, cut down on waste, and create a way more sustainable manufacturing process.
In healthcare, medical CPS is a total game changer. This covers everything from smart pacemakers that adjust themselves in real time to your body, to robotic surgery systems that let doctors operate with unbelievable precision from anywhere on the planet.
Then you have smart grids. They use CPS to manage the incredibly complex flow of electricity across an entire country. And that is absolutely vital if we're going to effectively integrate unpredictable renewable sources like wind and solar power.
And of course, the one everyone knows: autonomous vehicles. A self-driving car is basically a highly complex cyber-physical system on wheels. It's constantly crunching sensor data to navigate the world safely and efficiently.
So with an impact this big, it's no surprise there's a global race to master this technology. But, and this is a big but, all this power comes with some very significant challenges that we absolutely have to get right. If you analyze thousands of scientific papers on this topic, a fascinating story emerges. You can see these clear geographic specializations. It's not one single field. Different parts of the world are focusing on very different pieces of the puzzle.
For example, China is the undisputed world leader in research on smart grids. The US, on the other hand, is heavily focused on building security frameworks and medical applications. And Europe is really pioneering the use of digital twins in smart manufacturing and already looking ahead to Industry 5.0.
This brings us to the most critical challenge of all. In a CPS environment, a digital vulnerability can cause catastrophic physical damage. We're not just talking about losing data anymore. We are talking about real-world physical consequences from a cyber attack.
And the threats are serious. Attackers can flood a system to shut down an entire factory. They can tamper with sensor data, it's called spoofing, to trick the system into making a disastrous decision. Or they can just inject their own commands and take direct control of physical equipment. So you can see why defense is so essential. All of which brings us to the future, where the next great technological leap built right on top of CPS is already starting to take shape.
Researchers are now working on what they're calling cyber-physical artificial intelligence, or CPAI. The goal here is to make these systems not just autonomous, but truly intelligent and adaptive in ways that are kind of hard to even imagine right now.
But here's the fundamental conflict they have to solve. See, AI works on probabilities. It makes a best guess. Physical systems, on the other hand, demand absolute certainty. You can't have a surgical robot that's only probably going to make the right incision, right?
Successfully merging those two worlds, probability and certainty, is the key to unlocking the future of this tech. And it leaves all of us with a really critical question to think about as these systems become more and more a part of our lives. What happens when our world starts to manage itself?